Okay, sound and the speed of sound. Sound travels at room temperature air, which we consider that kind of an average temperature, and that's about 74 degrees Fahrenheit. It travels at 343 meters per second. If we transmit that or transfer that into miles per hour, we get 768 miles per hour. So we just said that Chuck Yeager broke the sound barrier in 1947, and he wasn't going that fast. He was going 662 miles per hour. Well, why did that happen? How can he go slower than what we say the speed of sound is in air and break the sound barrier? That doesn't make sense. So what we have to look at is we have to look about the time. Chuck Yeager did this in October, um, and this happened to be when the air temperature was not 74 degrees. He also was higher up in altitude above the Earth's surface. So there's a couple things that happen. It's easier to break the sound barrier at higher altitudes because the air has a lower temperature, the air has fewer particles, and so if you've got fewer particles and you've got lower temperature, you have less movement of those particles too. And so you've got cooler temperatures so that sound cannot travel from one molecule to the next very quickly. So it slows down. So the day that Chuck Yeager broke the sound barrier, in this case, obviously it was not 74 degrees. We know that. It must have been a lot cooler temperature, plus the altitude had less particles. So therefore, he was able to break it at 662 miles per hour. When there is also, when you have somebody who is trying to break the sound barrier, in this case, we don't try to break it anymore, it just happens. Sometimes what you hear a sonic boom. And you also can see, if you've got enough moisture in the air, you can see a shock wave. You can see the condensation wrap around that airplane. And you can check out some of the videos of some sonic booms in action and some shock waves on the next slide.